What's going on, friends? Generators are a more advanced feature in Python. A common use case is to work with large files. I believe the best way to learn is to work on projects once you understand the fundamentals. We are going to build a video streaming service using FastAPI. In this project, you will learn how Python generators can be a powerful tool for handling video data efficiently. As you can see, as soon as I play the video, an API request is made to the server. Small pieces of data are subsequently streamed back to the client as they are being retrieved from the data source. With this approach, users don't need to wait for a 500 megabyte video to be completely downloaded before they can start watching. The progress bar fills up as data is downloaded from the API. By the end of this lesson, you will understand why a generator is the perfect tool for this scenario. We are going to explain generators and their practical use cases. Then we will cover their implementation and finally the video streaming project. Now let's get started. Alright friends, to fully understand generators in Python, you need to understand both iterators and iterables. Any object that you can perform a loop operation on it is an iterable. Examples of iterable include string, list, tuple, dictionary, and so on. Numbers are not iterable because loop operation is not possible on them. Let's consider this example. We are trying to perform a loop on an integer. If I were to run this program, you would see that Python will raise an error. Let's execute the program. Type error, int object is not iterable. This is because we tried to loop over an object which is not iterable. I hope you now understand the meaning of an iterable. On the other hand, any object that implements these two special methods is called an iterator. These methods allow the object to produce its items one at a time. You use the iter function to turn an object to an iterator. The next function returns the next value in the iterator. Let's take a look at the second example. We have a list data type which is an iterable, and we've used the iter function to turn it into an iterator. Remember I mentioned earlier that an iterator produces its item one at a time. So we can use the next function to get the next item in the iterator until there's no more item. Let's make use of next of iterator. We want to print the result, the returned value, to the terminal. Let's execute the program. Great, as you can see, the next function returns the next element in an iterator. 1 is returned because 1 is the first element. So now let's make use of it a couple of times. Let's execute the program again to see what happens. Great, the next function returns the next element in the iterator. If I use the next function, Python raises a stop iteration error if I try to retrieve the next element and there is no more element present in the iterator. Let's run the program again. Stop iteration error on line 10, which is this line of code. Now that you have an understanding of iterables and iterators, let's begin exploring generators. Generators are a special kind of function. Whenever a normal function is called, everything in the function body is executed, and when it gets to the return keyword, the value you specify in front of the return keyword is returned back to the caller of the function. In this case, the summation returned is set to a new variable named total. In short, the return keyword terminates a function, so anything you write after the return keyword within the function is ignored. But when a generator function is called, it returns an iterator, meaning that it generates values one at a time. The generator function will continue to generate values until there are no more values to generate. Unlike a regular function which uses the return keyword, a generator uses the yield keyword. Let's take a look at this example of a generator function. Whenever you tell a generator function to give you a value, the function body is executed, and as soon as it encounters the yield keyword, the value you put in front of the yield keyword is returned. The good part about a generator is that when next you tell it to give you another value, it is able to remember that it stops here. So the second time you tell it to give you a value, the execution is going to start on this line, and a new value is returned when the yield keyword is encountered again. This is why generators are said to remember state, which means that they are able to resume execution from where they left off. Now let's call this generator function generate data. We would like to know the type type. Let's print the type to the screen. Print the type of generate data. Let's execute the program. As you can see, the type of what is returned is a generator. When I hover over the function, the code editor is showing that the return type is a generator. If you observe, you will agree with me that generators are iterators because they are able to produce or generate values one at a time. What that means is that we can use the next function to retrieve the next item generated by a generator. So now let's make use of the next function on a generator in order to get the next element or the next item in the generator. Let's say data, which is a new variable, equals generate data. Now we want to call the next function on the data. The first time you use the next function on the generator, the function body is executed, and as soon as it encounters the yield keyword, the execution is paused and the value in front of the yield keyword is sent back to the caller. The expectation is that if we run this program, these two lines of code are printed to the screen. So now let's execute the program. I'm just going to drag up the terminal. Now let's run the program. Great. Don't be surprised that the returned value is not printed. For us to be able to access the return value, we can either set it to a new variable or print it directly on the terminal. So now if we run it again, we should see batch 1 returned on the screen. Fantastic. So the second time you call next, the generator will resume its execution from where it stops. That means the execution will start from line 24. Immediately it encounters the yield keyword, the value is sent back to the caller. So now let's call the next function on the generator again to see the output. It works. Second set of data is ready, which is coming from this line, and the value that was sent back by the generator is batch 2 returned from this line on line 25. This process continues until there is nothing left to yield from the generator. At that point, a stop iteration exception is raised. Now let's call the next function on the generator the third time. Let's run the program. If we call it again, a stop iteration error will be raised because there is nothing left in the generator. Let me drag up the code editor. As you can see, stop iteration. This is because nothing is left in the generator. Alright friends, let's take a look at this infinite sequence generator. When you call the next function on the generator for the first time, the function body starts its execution. Whenever you come across while true, the loop body is expected to run forever, except if you introduce a break statement in it. Remember that this loop body will always run because true will always evaluate to true. So this means the first time you try to generate a value from this generator, 0 is sent back to the caller. Let's run the program to see the output. The second time you tell this generator to give you another value, the execution starts from here, which is line 40, because a generator is able to remember where it stops. So at this point, number equals number plus 1. This line 40 is equivalent to saying number equals number plus 1. So the value of number is going to be number, which is 0 plus 1. So that means the value of number is now 1. The loop body again is executed. For the second iteration in the loop body, the value of number is now 1, which means at this point yield 1. 1 will be sent back to the caller. Now if we execute the program again, we should get a value of 1. With this approach, we can generate an infinite sequence. Remember that you can always use a for loop with a generator. The for loop will run as long as the generator is yielding values. So now let's try to use a for loop on this generator. For each in sequence, print each. This is an infinite loop because this generator will always return a value. Now let's execute the program. As you can see, this program keeps running, except if you manually terminate the loop. I'm going to press Ctrl C. Alright, I hope you are beginning to visualize why generators are a good tool for operations involving large data processing. Generators improve the performance of an application because you don't have to process all the data at once. Instead, you can start delivering data to the users in small pieces as soon as they are available. Additionally, generators reduce memory usage because the computer does not have to load the entire dataset into memory at once. A common cause of application crash is outage memory usage. This happens when your program needs more memory than is physically available on the system. Alright friends, in addition to the yield keyword, yield from is another keyword commonly used in generators. If it turns out that your outer generator needs to generate value from another generator known as sub-generator, then you can make use of yield from. In such case, the value returned by the sub-generator is made available to the outer generator and the value is returned to the caller of the outer generator. Let's try out this example. Gen for generator equals outer generator print next, then we can pass the generator inside. Now if you call the next function on this generator, this function body is executed, and as soon as it encounters yield from, it knows that the responsibility of generating value has been transferred to another generator. So that means this generator is executed and the value returned by this inner generator is 1. This 1 is now returned to the outer generator, then returned back to the caller. The execution for the first time is going to return 1. If we call the next function on the outer generator again, the inner function is responsible for producing a value, which means that any line of code after the first yield is executed, then it encounters another yield, which is yielding the value of 2. The value of 2 is now sent to the outer generator and the value is returned back to the caller. So the value now is going to be 2, 1, 2. Alright friends, let's begin the video streaming project. The first thing we want to do is to identify the packages needed to get the job done. We are going to use FastAPI, a Python web framework, to serve requests coming from clients, and the Ginger2 template to serve an HTML page when a user visits a page on the web application. Let's document those packages by writing them into a file. Let's create a file named requirement.txt. These are the packages needed and their versions. UVCon is used as the web server. Now the next thing we want to do is to create a virtual environment. Virtual environment is like a container to keep the dependencies of this project separate from another project. Let's make use of the Python 3 command to create a virtual environment in this directory, venv. As you can see, a new directory has been created, which is a virtual environment. Now we have the virtual environment created. Let's activate it by using this command source venv bin activate. Great, as you can see, the virtual environment has been activated. Now the next thing we want to do is to install all these packages in the created virtual environment. Let's do pip install -r requirements.txt. We are now installing all the libraries needed. Let's create a module which is going to be the entry point of our application, touch main.py. Alright, let's import the relevant classes and modules from the FastAPI package. From FastAPI, import FastAPI. We also need to import request and status. From FastAPI.templating, import Ginger2 templates. We can now initialize the app by creating an instance of the imported FastAPI class. Let's say app equals an instance of the FastAPI. As you can see, when I move the mouse over the FastAPI class, it shows that it takes a couple of arguments. Let's just pass the title as video streaming. Title equals video streaming. Also, we are going to use the Ginger2 templates to specify the location of the HTML files to be used. We are going to say templates, a new variable, equals Ginger2 templates, which is an instance of Ginger2 templates Jinja2 templates is also a class. So we can pass the directory of the template. The directory of the template is going to be templates. What that means is that we need to create a folder or a directory named templates. That is where our HTML files will be kept. Let's create a folder called templates. Alright, we have the folder created. Now let's start defining the URLs or the APIs. The first URL we want to serve is when a user sends a GET request to the root of a domain such as readonread.com. We are going to say at app.get, which means a GET request, and the path, which is the same as the URL, is going to be this. When you are on a local machine, the root URL will be served at localhost port 8000 on port 8000. Whenever a user visits the root, we need to define a function to handle the request. Let's name the function home async def, which is for creating a function home. It takes the first parameter as request and the type is request, which we have imported. Return, we want to return an HTML templates response. We are going to pass the name of the HTML template. Let's call it index.html. We also need to pass the context, which is expected to be a dictionary. Contexts are extra information you want to send from a route, that is from a URL to the HTML template. So let's say context equals a dictionary, and the first item we want to pass is request, which is this request. Let's also pass the title. We are going to call the title FastAPI video streaming. FastAPI video streaming. Let me format this document. So whenever a user visits the home page, we want to return an HTML template to them. The name of the template is index.html. Let's go ahead to create the index.html template. I'm going to create a new file here called index.html. So for the content of this index.html, it is going to be a basic video tag. As you can see, this is a basic HTML page with some stylings. Yeah, so this is the video tag we want to use. Like I mentioned to you, you can send some information from the route to the HTML template. The title we are sending from the route can be captured as title here. We just need to use these double curly braces. Now what we want to do is to run a local development server. To start the local development server, I'm going to copy the command from the FastAPI documentation. Alright, so this is the command uvcon main app reload. So let's go to our project. Let me open up a new terminal. As you can see, uvcon main app reload is the command to run the FastAPI application. Main is pointing to this file, that is this main module. Then the app you pass to it is the app defined in the main module. Alright, so now let's go ahead to run this command to see what happens. So now let's copy this URL to visit the website. Great, as you can see, immediately we visit the home page, a 200 response code is sent back to the client, which means that everything is fine. Now let's try to play the video to see what happens. Another API call to stream video is detected, but a response code of 404. 404 means the URL is not found or it is not defined in this application. If you look at this HTML file, as you can see, the API call specified for the source of the video, which is stream video, is not defined in our application. Now, this is a good time to define the API call to handle the video streaming. Let's go back to the main.py module. Now, let's define another route to be handled in our application. We want to define a GET request to stream video. Let's define the function to handle this route, async def, which is for defining a function. Let's call the function stream video, stream_video. We we need to pass the first parameter as request and the type is request. Since we intend to start sending chunks of data to the client as soon as they become available, we need to use a response called streaming response. So let's go ahead to import the response from FastAPI.response import streaming response. Let's head over to the documentation to see how the streaming response works. For us to be able to use a streaming response, we need to pass a generator. Streaming response takes an async generator or a normal generator or iterator and streams the response body. Let's go back to our code to continue the implementation. So it means that we need to return a streaming response. The generator name content equals, the generator name is going to be generate video chunk, generate underscore video underscore chunks. Now let's go ahead to define these generate video chunks. Def generate video chunks generator pass. Within this generator, we need to access the data source, which is the video file, and read a certain part from it. Let's scroll up to define the location of the data source. Video underscore file equals a string, let's call it video.mp4. And the chunk size we want to read at a time, chunk underscore size equals 1024. In this generate video chunks generator, we want to open the video file and read a certain part from it. Let's make use of context manager to open the file with open the video file. Let's specify the video file, and the mode of reading is going to be read binary as file object while true chunk equals the file object, and we want to read a certain part from the file object. Let's pass the chunk size, which specify the size of what we want to read from the file. If not chunk, that is when the chunk is an empty string, we want to break out of the loop. Otherwise, we want to yield the chunk, Essentially, you make use of this kind of loop when you don't know in advance the number of times a code block will run. This code block is going to run forever if you don't break out of the loop. If not chunks, this means when an empty string is returned, which marks the end of the file. Lastly, you want to send the chunk read to the caller of the generator. Suppose you have a file with this content A, B, C, D, E, F. If the first call using the read method stops here, the next call is going to start from here, which is letter D. So at some points, it will return an empty string, which is when there is no more content available. Now, the next thing we want to do is to specify the headers when returning the chunks. Let's say headers, which is a new variable, equals a dictionary. We need to specify a couple of information here. First, the content type, video/mp4, and also the accept ranges, bytes. We also want to specify the content encoding. The value is identity. And also we need to specify the content length, which is the size of the file. For us to get the size of the file, which is the video file, we can get it from the file object. To keep it simple, let's make use of the OS module. Let's say file size equals, we need the OS module. Let's import the OS module. Import OS. So we can say os dot start, then the video file dot st size. This is going to return the file size as an integer. The return type is an integer. So we want to make use of the file size in the contents. File size, let's convert it to a string data type. Finally, we need to specify the content range. Content range equals content range f strings, which is start from 0 to the file size -1. divided by the file size. All this information are needed by the browser to know how to handle the streamed content. Now let's pass the header. Let's say headers equals the headers we've defined up here. Also, we would like to pass the status code equals status. I believe we've imported status. Yeah, we've imported status dot http 206, which is a partial content. Now we need to specify the media type. The media type is video/mp4. Let me format this document. Before we move on, let me print a counter on the screen to keep track of how the chunks are generated. I'm going to initialize the counter here. Counter equals 0. Then before the yield, counter equals counter plus 1. Print chunk counter. Also, let's print something on the screen when the chunks end of chunk. The first time this generator function is called to produce value, it opens up the file. Since true is true, this block is expected to run. A chunk is then read on this line. If the chunk is empty, then we want to break out of the loop. Otherwise, yield chunk, which means a specific chunk is returned to the caller. The second time you call the generator to get data, it resumes the next line following yield, because generators are able to remember the state or the point where they left off while true. So this block of code is executed again, which means another iteration is performed. This process continues until the file content is empty. Let me look for a video file to put in this directory, video.mp4. So I'm just going to put the video in this directory. Alright, now let's go ahead and try out the app. 127 on this port. We have a new request to the home page. Now let's play the video. Great, as you can see, the chunks are being generated. This is the progress so far. So the chunk generation is still in progress. I can play the video right now. We want to be able to access the content of the product module and the helpers module. The first and the error module. With this approach, we don't need for the whole file or for the whole video to be downloaded at once before the user can start watching the video. As the chunks are being generated, they are streamed back to the clients. Alright friends, I believe by now you have a proper understanding of generators. Something you might want to consider is connecting to a cloud storage like AWS S3 buckets or Google Cloud Storage as the data source of the video. For now, the video is sitting on the local server. Also, HLS video format can be considered. HLS involves separating a single video into separate files, so contents are streamed to the front ends as they are being requested. I hope you enjoyed the video. Please like, comment and share. Thanks.